We've talked about how to use the double angle formulae. Let's try to solve this problem. So let's say you had to find the sine of 67 degrees and 30 minutes. Now 30 minutes just means half degrees, so this is just 0.5 degrees. So essentially you need to find the sine of 67.5 degrees. Now 67.5, even though it might seem terrifying, it's just half of 135 degrees. So it's always good to try to double that number that you have to figure out a way to approach it. Now we do know what is the sine of 135. That's just equal to the sine of 180 minus 45 degrees. And we know that this is just equal to the sine of 45 degrees, or 1 over square root of 2. But the sine of 135 over 2, to do that, what we can do is let's refer back to our double angle formulae. Now, if you wanted to start out by using, let's say, the sine of 135 degrees, since it's the double of 67.5, it's equal to 2 sine of 67.5 degrees times cos of 67.5 degrees. This doesn't help us that much, since we only needed to find the sine, but then there is another term involved here, cos, and it just increases our workload. How about if you use the cosine part instead? So the cosine of 135 degrees, if you wanted to write it in the terms of the sine of this individual angle, in that case you can write that the cosine of 135 degrees is equal to 1 minus 2 sine squared of 67.5 degrees. And now this problem seems a lot more approachable. So cos of 135 degrees, that is equal to the cos of 180 minus 45 degrees, or negative cos of 45 degrees, or negative 1 over square root of 2. So just put that in right here. So negative 1 over square root of 2 is equal to 1 minus 2 sine squared 67.5 degrees. This just gives you the fact that sine squared of 67.5 degrees is equal to 1 plus 1 over square root of 2 over 2. This is a lot easy. You can take square root on both sides, so this just becomes sine of 67.5 degrees is equal to the square root of 1 plus 1 over square root of 2 over 2, which is just the square root of 2 plus the square root of 2 over 2. Now notice you didn't include the positive negative sign here, and the reason for that is that we know that 67.5 degrees lies in the first quadrant, wherein the sine of the angle is always positive, so there is no chance that this number can ever be negative. Now let's use the ideas that we developed here to get a more general expression. So just as in the way of writing the double angle formulae, we took the trigonometric ratios of an angle A and converted them to that of 2A, what we can do is we can write the same expression backwards. So you can start out with some angle A and write it in terms of the trigonometric ratios of half that angle. So now the formula that we had before, these just become the sine of A is equal to sine of 2 times A over 2. And this is just equal to 2 times sine of A over 2 times cos of A over 2. Similarly, cos of A is equal to cos of 2 times A over 2. Notice I'm just going by the approach that we had already discussed about. This is either equal to 2 cos squared A over 2 minus 1. You can write it this way, or 1 minus sine squared A over 2. And the last one is that tan of A is equal to 2 times tan of A over 2 over 1 minus tan squared of A over 2. Now notice that in all of these expressions, the two most helpful ones are right here. That one that cos A is equal to 2 cos squared of A over 2 minus 1 and 1 minus 2 sine squared of A over 2. These are the most helpful ones. This one is a bit difficult to solve. This one requires some other counterpart. If you wanted to figure out the sine, you also need to factor in the cosine. If you wanted to figure out the cosine and sine, that vice versa thing happening here. If you just use the equalities that we have in the second part, what you can do is you can write two things from here. First, that 2 cos squared of A over 2 from this equality that we have here, this is equal to cos of A plus 1. And so what that means is that cos squared of A over 2, that is equal to cos of A plus 1, all of that divided by 2. If you take square root of both sides, you can write that cos of A over 2, that is the cos of the half angle, this is equal to the square root of cos of A plus 1 divided by 2. And now you do need to include the positive negative sign while stating this formula. And the reason for that is that we don't know where will A over 2 lie. So if A over 2, let's say, lies in this region, that is the first or the fourth quadrant, then there will be a positive sign. If not, if let's say it lies in this region, the second and the third region, then you will have a negative sign. So just to be clear, this does not say anything about that the cos will have two values. What it just says is that this sign will depend on the fact that where does this angle A over 2 lie. So if let's say A over 2 were here, then you will include a negative sign there. Now, you can do similar things with the sine part as well. So if you just use this, cos of A is equal to 1 minus 2 sine squared of A over 2. You can write that 2 sine squared of A over 2, that is equal to 1 minus cos of A. This will similarly give you the fact that sine of A over 2 is equal to positive negative 1 minus cos of A over 2. Again, this positive negative sign depends on the fact that whether the sine of that angle in that particular quadrant of the two-dimensional plane is positive or negative. If you wanted to just figure out what is tan of A over 2, you can simply just divide the sine of that angle by the cos of that angle. And since there is a positive negative sign involved, let's not make any assumptions. Let's just include a positive negative sign. We don't know about the sine of the tangent. And this sine is getting divided by cos. So you will have 1 minus cos of A divided by 1 plus cos of A. This over 2 things will cancel out. So these are your half angle formulas expressed in terms of cosine. A quick note though, there are many cases wherein you need to express everything, every half angle, in terms of its tangent, and this occurs quite a lot of times in calculus. And what you do here is the fact that you start with the equality that tan of A is equal to 2 times tan of A over 2 divided by 1 minus tan squared of A over 2. And if you imagined a triangle, a right angle triangle, and in that right angle triangle you have this angle A, the tangent of that angle A is equal to this ratio. So let's take it that the scale is just 1 to 1. So let's just make this opposite side to be 2 tan of A over 2. And the base will be 1 minus tan squared of A over 2. In that case, you can write the hypotenuse as the square root of 1 minus tan squared of A over 2, all of this squared, plus 2 times the tan of A over 2, all of this squared. This is just by the Pythagoras theorem, by the way. This will just give you 1 plus tan squared of A over 2. And from here, you can now easily write the fact that cos of A is equal to the base over hypotenuse. So 1 minus tan squared of a over 2 divided by 1 plus tan squared of a over 2. And similarly, you can write that sine of a is equal to opposite divided by the hypotenuse. So 2 tan of a over 2 over 1 plus tan squared a over 2. So there you go. These are the half angles and the double angle relation in terms of the tangents. Here you go with the cosine. We already discussed about the double angle approach. See you in the next video.